So today's final speaker does her work, much like Harry Potter, maybe Hermione or something, on the very border between reality and fantasy. Jacqueline is a professor at the Department of Psychology at the University of Texas at Austin and leader of the Imagination and Cognition Lab. Jacqueline is internationally acclaimed for her work on how children evaluate the reality status of novel instances and events, and she has done extensive work on the conceptual development in preschool and elementary school children, including topics such as their perception of reality and possibility, the role of testimony in children's beliefs, and the development of scientific and supernatural reasoning. As we've heard from many of the speakers today, children spend considerable time immersed in fantastical worlds. They watch cartoons, they leave cookies out for Santa Claus, and they dress up for Halloween, and they of course pretend to play. While we may be inclined to think that some children very easily could get all of these realities confused, Jacqueline has done some incredibly interesting work showing that young children in fact have sophisticated tools for distinguishing between these realms and use a wide range of cues and strategies to make reality decisions. So I've been looking very much forward to this talk. Jacqueline, as I'm sure everyone else has, please.
Thank you. Thanks, and thanks for having me. This has been really fun. The metaphor of the child as scientist, formulating theories about the real world, has motivated a lot of research in the field of cognitive development. And from that research, we know that children know quite a lot about the ordinary nature of things. And in particular, as Alison mentioned, we know that they form theories about the world. They form naive theories of physics. They form naive theories about biology and about psychology. And a much smaller space, though, has been devoted to the question of how children think and reason about what's not real. And that ability to imagine the impossible has motivated my research for a number of years, and today I'll tell you about some of the findings from that research. Basically, my focus will be on how children come to make the distinction between reality and non-reality, what tools they use to make that distinction, and then how understanding children's ability to make that distinction can tell us more about cognitive development more generally. So children face a wide range of reality, non-reality distinctions pretty much on a daily basis. So they have to understand, for example, when their older brother is really angry with them versus when maybe he's just pretending to be angry. They have to understand the distinction between, say, a real cookie and a pretend cookie for pretty obvious reasons. Maybe most notably is that Play-Doh tastes really disgusting, so you don't want to make that mistake. You also, if you like cookies, it's probably best if you go and get one versus if you try to kind of conjure one up with your imagination. So children need to learn all of these kinds of things. They need to know that even though putting on a cape could give Batman special powers, or it could allow Superman to fly off a tall building, they need to know that just putting on that cape won't afford them those same capabilities. So there are a lot of important distinctions within this realm that children need to know, but really there's nothing uniquely childlike about making these kinds of distinctions. Adults do this kind of thing all the time. So when we're reading fiction, when we're imagining the future, when we're trying to differentiate real news from fake news on the internet, all of these things. In fact, I did this last week at the San Francisco Museum of Modern Art. Why do people like this painting so much? I think one of the reasons is it really forces us to imagine the impossible. So maybe when we're looking at this painting, the first thing that we think of is, gee, could this be a really big apple? Maybe not. Then we think, well, maybe could it be a really small room? And then we think, well, possibly, could be. And then we kind of, maybe our eyes drift over to the side and we look at perspective, and maybe that kind of gives us some clues about all of this. And I think that what we're doing when we're looking at this painting is we're imagining the impossible, but importantly, we're using lots of real-world skills to do so. So when we reject the idea that this is a giant apple, we're using our biological theories. When we think about whether this could be maybe a really small room, we're using our knowledge about people's intentions and goals. And then, we're using our perspective-taking skills when we kind of look out the window and reason about what could be going on with that. So part of what's going on is I think imagining the impossible is just really fun and pleasurable, and so we like looking at paintings like this for that reason. But it's also really important because we are actually drawing upon all of these important theories about the world. And I'll submit that it's especially critical, though, for children to get this distinction between reality and non-reality right, because this distinction between what's real and what's not real, between what's possible and what's impossible, forms the foundation for these naive theories that I've just mentioned. And we adults don't make it easy on children. So children are faced, again, on a day-to-day basis with real and fictional characters performing both possible and impossible events. So Elmo, who is a monster, teaches children science. Dora, do you guys know Dora the Explorer? Okay. So Dora is a human girl, but she has a talking backpack. And then we also teach them about all kinds of cultural beings and cultural myths featuring various kinds of entities in which we would have them believe. So the traditional claim about children's abilities in this regard is that they have difficulty differentiating fantasy from reality. And there are lots of behaviors that children engage in that might make the naive observer think that they have trouble. So as we've talked about already, they spend a lot of time in these pretend worlds. They spend time socializing with imaginary companions. They believe in magic. And as I mentioned, they endorse a wide range of fantastical beings like Santa Claus and the Tooth Fairy. Because of this, many have argued that children are unthinkingly credulous, that they believe everything that they hear without any kind of evaluation or discernment. And what I'll suggest today is that children, in fact, are often skeptical, and they use a variety of different tools to make this distinction between reality and fantasy. I keep forgetting that I have this and walking over here. I've never used one of these. How do you get with the program, I guess? So the basic paradigm I use involves presenting children with novel entities and then either observing or manipulating various factors of interest and then assessing children's beliefs about whether the various entities are real or pretend. What these studies reveal is that children use a variety of tools to make the distinction between reality and fantasy. So I'll talk about two kind of broad categories of tools. One is by using cues in the immediate environment, and the second is by using their existing beliefs about reality. And then within each of these, I'll discuss some specific abilities that children have. I'll show that children increasingly use physical evidence to reason about what's real and what's not real, that they pick up cues in the conversations of other people, and that they consider the context in which they encounter a novel entity in making these kinds of decisions. They also use their existing beliefs about the reality status of entities that are associated with the novel information. They think about what exists in the real world, and then they assess the fit with that information with the novel information, and then kind of use the output of that calculation to decide what's real and what's not real. And then they also use assessments of their own expertise to make these kinds of distinctions. So behind what might seem a simple judgment about whether something's real or pretend lie all of these sort of complex, scientific, analytical kinds of abilities. So we started this line of research by looking at children's beliefs about fantastical beings. And one difficulty in studying children's beliefs about fantastical beings is that by the time they come to the lab, they've already heard about, say Santa Claus, for example, from a host of different sources, from their parents, from their peers, from movies, from books. And so it's really hard to kind of isolate, the different variables of interest. Also, by the time they come to the lab, they already believed in Santa Claus or, these other fantasy figures. And so again, it's really hard to sort of study the factors that affect belief. And so what we did to kind of circumvent that was we created a new fantastical being, and we presented it to children. This fantastical being, this is a depiction of the fantastical being as the Candy Witch. We've never seen the Candy Witch, so we couldn't come up with a real photograph of her, but we found a photograph of what people think she looks like. And so what we did is we went to the preschool, and I know that Halloween is sort of emerging here as a popular holiday. At least I've heard that. Is anybody not familiar with Halloween? Okay, so it's a thing here. So what we did is we went to the preschools and we talked to children about Halloween, asked them what you do on Halloween, what happens on Halloween, and then we asked the children if they'd ever heard of the Candy Witch. They said no, and we introduced the Candy Witch to them, talked about what she did, what she was like, showed them that picture. Then we went back about a week later and made paper bag puppets of the Candy Witch with the kids. We had a different researcher go each time, so children would hear about the Candy Witch from multiple sources, and they would experience multiple activities around her. All of the children participated in this. Then we sent permission letters home to the parents to see if the parents would get involved. And here's what it takes to be involved. So basically, what the Candy Witch does is she flies around and visits children's houses on Halloween night, and she really loves candy. And so what she does is she takes whatever candy the children are willing to put out for her, and she replaces it with a new toy. Okay, and it was important, we didn't want to tell children they had to put all of their candy out because we thought then none of them would want to do this. So we basically told them that, you know, you can put out some or all, however much of your candy that you want, and then the Candy Witch will replace it with a new toy. So what we had to do is we had to get parents to agree to do this in their homes. Basically while their children were sleeping, or at least to arrange putting the candy out. While their children were sleeping, they had to do the little candy toy swap, and then, you know, sort of see what would happen. So essentially, we're asking parents to bring a new fantastical being into their children's lives. So we sent out a bunch of permission letters, and we ended up with 25 parents who were willing to do this, and a control group of 19 parents who were willing to have their child hear about the Candy Witch at school and be questioned about her, but they didn't want to do this witch at home. So we ended up with an experimental group of children who were visited by the Candy Witch, and then a control group of children who were not visited. And then after all of this, we went back within a week of Halloween and assessed children's beliefs in the reality of the Candy Witch. Okay? And I just want to show you a little video that gives you a sense of what children told us about the Candy Witch. And if I just double click this. Oh. Okay, well, in order for this to work, obviously we had to get some kids who believed, like some of these kids, but we also had to get some variability so that we could study what we were interested in. So as it turned out, children believed in the Candy Witch almost as much as they believed in Santa Claus. But there was also variation. Some kids didn't believe as strongly. So that enabled us to explore a number of factors that we thought might affect belief. The one that I'm going to talk about today is age. So what you see here is younger children on the left and older children on the right. It's just younger preschoolers and older preschoolers. They were all in preschool. The blue bars are children who were visited at their home by the Candy Witch, and the red bars are children who are not visited. And on the y-axis is just a combination of their belief and certainty level. And what stood out to us and what surprised us was that among the children who were visited, that the older children believed more strongly than did the younger children. And we sort of thought it would be the opposite, that the younger children would be more credulous and the older children would become more skeptical. And so we kind of puzzled about what could be going on, and one of the explanations that we came up with was that maybe the older children were better able to use and reason about the evidence that they received. So basically, their candy was gone, there was this new toy in its place, the candy witch was the only being that they could think of who did that sort of thing, therefore she exists. So to try to study whether this is actually going on, I just want you to think for a minute about what kind of evidence might be involved in reasoning about, a familiar being like Santa Claus. So one type of evidence that you might receive is relevant evidence. So we know that Santa Claus delivers presents on Christmas Eve, and so when you wake up in the morning and you see presents there, you have evidence that Santa Claus really exists. You might also encounter, I guess, what you would consider irrelevant evidence. Like, for example, maybe you get a present on your birthday from your grandmother. Doesn't really tell you anything one way or the other. And no evidence. So maybe on Christmas Eve, before Santa Claus is supposed to come, there are no presents. That doesn't really tell you anything either. And so Ansley Tullis and I were interested in whether children use these different sorts of evidence. So this is the first category, physical evidence. Whether children use these different sorts of evidence to reason about the existence of fantastical beings. So we did a study that worked in the following way. So we started by showing children boxes, and we told them that a vet used these boxes, a veterinarian, used these boxes to transport animals back and forth from her lab. And this particular vet had 2 stacks of cards. One stack of cards listed all of the animals that she had been transporting, and the other stack of cards listed names that she had made up for future animals that she might discover. And sadly, this vet had gotten all of her cards all mixed up, and so the child's task was to help us sort the cards into the proper boxes of real animals and made-up animals. And so we told children about a bunch of made-up animals. One, for example, was called a taquine, and we told them various properties about the animal. So we told them that, for example, taquines always eat twigs, and so they always leave little bits of twigs behind everywhere they go. And then we showed them different kinds of evidence inside the boxes. So for example, we showed them supporting evidence, like I just discussed with regard to the Santa Claus example, irrelevant evidence or no evidence. So for the taquine, for supporting evidence, they would see a bunch of twigs in the box, or they would see something irrelevant like a feather, or there would just be no evidence. And then after they saw the particular type of evidence, they would be asked whether the entity was real or not real. So basically, there were kind of 3 parts to our questions. The first part was just an identity question. So could kids identify what type of entity had been in these boxes? And the idea here is that without an ability to make an accurate identity judgment, reality status judgments are going to be kind of impossible. The idea is that these reality status judgments kind of rest on this basic scientific ability to use evidence. So they were first asked whether they thought something was in the box, and if they said yes, we asked them what did they think was in there. That was the identity question. Then we asked them if they had enough information to tell whether the particular kind of entity was real or not real. And if they said they could tell, we asked them whether they thought taquines were real or not real. So this graph shows you performance on the identity question. I'll kind of walk you through it. There's a lot of bars. On the y-axis is the identity score, and this just means out of 2, how many did they get right? How often did they correctly identify what kind of animal was in the box? The black bars show when there was supporting evidence, like twigs. The gray bars show when there was irrelevant evidence, like the feather, and then the white bar is when there was no evidence. So the main things to see from this graph are, first of all, that as children got older, they got better at using evidence. So they more often used supporting evidence to conclude that this kind of animal was in the box, that it was a taquine that was in the box, for example. And they were less likely to use irrelevant and no evidence to make these judgments about what had been in the box. But the important thing is that their ability to use evidence kind of undergirded their ability to make these reality status judgments. And I'll explain that with these next few graphs. So what I've done here is divided children into successful and unsuccessful groups. The unsuccessful group were children who couldn't use the evidence to identify what kind of animal had been in the box, and the successful children were those who could use the evidence to identify what was in the box. And this is across all ages combined. And basically what happened was in the unsuccessful group, the kids who weren't able to use the evidence to identify the animal, it didn't really matter for reality status what kind of evidence they got. So they judged basically at chance, regardless of whether they got supporting, irrelevant, or no evidence. Whereas in the successful group, children used the evidence appropriately to come to conclusions about whether the animal, tachin's, for example, were real or not real. So if they received supporting evidence, they claimed that tachin's were real animals, whereas irrelevant or no evidence only justified some level of doubt or uncertainty. So this, what might, again, seem a simple task of saying whether something is real or pretend, rests upon these really important scientific skills, the ability to use evidence to identify the identity of an entity. So with age, children also become better at using other kinds of cues. The one that I'll talk about next is cues that they observe in the conversations of people around them. So various lines of research has shown that children are continually exposed to conversations that aren't really intended for them, and that they actually pay attention to these conversations, and they actually can learn from these conversations. And one really important thing to think about is that we don't often use, if ever, use reality to mark unambiguously real things. So I'm very unlikely to say something like, I believe in bananas, or forks are real, or something like that. We just don't do that. And so it seemed conceivable that maybe children would kind of pick up on these kind of subtle cues to what's real and what's not real. We never say I believe in forks, and so maybe they're sort of, whereas when we say something like, I believe in God, maybe they kind of pick up on, well, why is she saying that? And how is it maybe different than something like forks? So with Lili Ma and Gabe Lopez Mobilia, we explored whether children pick up on these cues in other people's conversations. So what we did is we presented children with videos of two people talking, again, about novel entities. And they talked about them in a few different ways, 3 different ways. One was they made an explicit belief statement. So they said something like, oh, dugongs are real animals, or I believe in dugongs. So really explicit statements of their belief. Or they made what we call implicit belief statements. So these are the kinds of statements that we use when we just have a conversation about something with somebody else. So they said something like, oh, I saw a baby dugong being born, or we had a class project about dugongs. Then we also had a condition in which people just denied the existence of the entity. And then finally we had a control trial just to ground kids in their performance and see if they were paying attention with some familiar trials. We just called that the known real trials. And kids got 2 of each type. And after listening to all of these conversations, we just asked kids whether they thought these different animals were real or not real. Okay, so a lot going on here. I'll walk you through this again too. On the left is the number of claims that these various entities were real. We tested 3 to 9-year-olds. The leftmost, the lightest colored bar is the known real trials. That's the familiar animals, kind of a control KR. The next darkest is explicit belief, or EB. The next is IB, implicit belief, and then finally the black bars are the denial trials, where they just said that the entity wasn't real. So 3 patterns to notice from this. One is if you just look at the black bars, 3-year-olds were using these types of statements, but children got considerably better with age at using the denial types of statements to reject the existence of entities. If you look at the next bar over, or from, it's the best way to do this. I think, look at not the known real, but, oh, I have a laser pointer. Okay. Not the known real, but this bar here, the next darkest. So those are the explicit belief statements. And what's interesting about those is you kind of see an inverted U-shaped curve, where the middle-aged children are kind of using these more often than are the older children and the younger children to infer that these kinds of entities exist. And then finally, the implicit belief, that's this one here. But, you know, the 3-year-olds aren't using it levels greater than chance. The 5-year-olds aren't either, but by age 7, children are using these implicit statements like, you know, we had a class project on dugongs to come to the conclusion that dugongs are real things. So just in case it's easier to sort of summarize it verbally, 3-year-olds responded not real when the speakers explicitly denied the entity's existence, so they were using the information in these overheard conversations to make reality status judgments by this pretty young age. By age 7, children use these implicit statements of belief to infer real existence at levels greater than chance. And by 7, they did this and they explained their judgments. They said things like, because she did a class report on them. Or, if they weren't real, how would someone bring it into their classroom? That's great, I love these. But 5 and 7-year-olds were equally likely to respond real on the explicit and the implicit belief trials. And it wasn't until 9 that children were more likely to claim that the novel entity was real on the implicit trials. Like I saw a baby dugong being born, than on the explicit trials, where people said things like, I believe in dugongs. And the explicit trials by this age group, children were starting to be a little bit skeptical about these kinds of claims. So one child said, a 9-year-old said, you can tell they're not real because they said, I believe, you know, like I believe in monsters. So overall, you know, with age, children increasingly use the way people talk about these kinds of things to make decisions about whether these kinds of things were real or not real. So the third little subcategory under number 1 is context. So just to illustrate what I mean by this, imagine that you've read about a new kind of fish. Let's call it a cernet. And now imagine that you read about it in National Geographic, let's say. My guess is that having read about a cernet in National Geographic, say, is going to lead to a higher level of belief than if you read it in something like a tabloid like we have in the United States called the National Enquirer, or perhaps BT. Anybody read that? Don't read it. So adults use context. We use context, the context in which we encounter new information. We use context to come to conclusions about what's likely to exist and what's not likely to exist. So in 3 studies, Jennifer Van Riet and I explored whether children also use context. And we divided children into 3 conditions of scientific, fantastical, and everyday context conditions. And we manipulated context in 2 ways. First of all, we either read children a fantastical or a scientific or an everyday story before they engaged in the task, thinking that maybe that would prime something or kind of make certain categories be more salient for them. And then we also defined the novel entities with reference to either a scientific entity, like a scientist, or a fantastical entity, like a dragon, or an everyday entity, a child. And we really didn't know which manipulation would work, so we just sort of piled them all on at the same time. We gave both manipulations to all children. And after encountering these novel entities, we asked children to judge whether they were real or not real. This is an example of one of our descriptions using the cernet. So in the scientific, you'll see the middle sentence is always the same. We just sort of put that in there to make it flow better, I guess. The scientific condition children heard that, you know, we asked them, have you ever heard of a cernet? They said no. We said, well, scientists like to try to catch them. Cernets are usually medium-sized. Scientists collect cernets. And then for the fantasy condition, we used dragons and said basically the same thing. And then for the everyday condition, we used children and said basically the same thing. So they each received similar descriptions, but with reference to different levels of entities. And then we asked them if cernets are real or pretend. So what you see here on the y-axis is the proportion of novel entities that kids judged as real. The white bars are the fantastical context condition, and the hatched bars are the scientific context condition, and the black bars are the everyday condition. Just looking at the graph, the 3-year-olds, proceeding kind of chronologically, if you focus on the 3-year-olds, they didn't appear to use context to make these kinds of decisions. The 4-year-olds did, though, so they judged entities that they encountered in a scientific context as real more often than they judged entities that they encountered in a fantastical context. And the 5-year-olds did as well, and in this study, the 5-year-olds also used the everyday context as a cue to indicate that things were real. So they judged entities that they encountered in both the scientific and the everyday context as real more often than entities that they encountered in the fantastical context. Now, one thing that we couldn't tell from this study was which type of context was having the effect. Was it reading those stories beforehand, or was it those descriptions that I showed you? Since we used both, we didn't really know. So we did a second study in which we assigned children to 4 different conditions. So they either heard a scientific story beforehand, or they heard a fantastical story beforehand, or they received a description of the entity that referred to, say, a scientist or a doctor, or they heard a fantastical description that referred to the entity in terms of a dragon or a ghost. This graph with the pretty colors, I'll call it purple and burgundy. So they judged 5 entities, and on the y-axis is the number of entities that they judged as real. The purple bars are the story beforehand, and then the burgundy bars are the description. So as you can see from this, the story that they heard beforehand didn't really have any effect. That didn't work out, or didn't matter. But what mattered was the description that they heard of the entity. So if they heard about cernits as something that scientists collected, then they were more likely to say that cernits were real than if they heard that cernits were something that, say, dragons or ghosts collected. Some of the children gave us cues to what they were thinking. They said things like, they're real because scientists collect them, or all scientists are real, so I can tell. So children were using their existing knowledge about what's real and what exists to reason about these novel entities, which I think is pretty cool. One question that we had, though, was why 3-year-olds didn't use context. What was going on with the 3-year-olds? We were curious about the 3-year-olds. And one possibility is, we know that 3-year-olds are still kind of working out what's real and what's not real. They don't necessarily know, whether maybe ghosts are real or dragons are real. And of course, if you, think that ghosts are real, then, the fantastical condition and the scientific condition are basically going to be the same thing. So there's not going to be any kind of condition difference if you, are confused about whether the various things are real or not real. So in the course of the experiment, we had children judge the reality status of all of the different entities that we used to create these different contexts. And so we were able to divide kids into what we call passers or failers. Not very creative, but passers were children who were correct about the reality status of all of the entities that we used to define the various novel entities. And then failures were children who were mostly incorrect about what was real and what was not real. And collapsing across age, what you can see here is, on the left, you see that distinction between the different types of context. So for the passers, if they heard about an entity in a scientific or an everyday context, they would judge that it was real more often than if they heard about it in a fantastical context, whereas for the failures, there was no effect of context. And this was true even for the 3-year-olds. So we think that what was going on in the 3-year-olds was for those kids who were clear about what was real and what was not real, they were actually able to use context once we kind of took out the ones who were unclear about what was real and what was not real with regard to our familiar entities. Okay, so moving on to kind of the second broad category of cues that children used. We were also curious, this is actually kind of very related to that context cue, but I've separated it here. We were curious to know whether children also use context to reason about events. So far I've mostly talked to you about novel animals and beings, but what about events? Would they do the same thing if they heard about different kinds of things that could or couldn't happen? And religious stories are sort of a puzzle to those of us who study children's fantasy beliefs. They often contain a mixture of realistic and fantastical elements. So very often, ordinary people are granted special powers or various events that defy scientific principles. All kinds of impossible things are happening, like people living in the belly of a whale and escaping from the whale, or people parting a river with their hand. All kinds of impossible things, but they're conveyed to children as historical accounts. So what do children think when they hear these kinds of stories? So look at this. Victoria Baden and I presented children with a series of impossible events from the Bible. We presented them with, there were two conditions, a religious condition and a non-religious condition. And we also had two types of stories. We had two familiar stories and two unfamiliar stories from the Bible. So one of the stories that we used was a story about a man named Moses who parted a river with his hand. Children heard the story about Moses, and then at one point in the story, the kids in the religious condition heard, for example, the Israelites called to God for help, and God told Moses, "Do not be afraid. Stretch out your hands over the sea to part the water." The children in the non-religious condition heard the same story, but with all religious references removed. So they heard about a man named Matthew. And in that version of the story, Matthew's people, the Isonites, called to Matthew for help. And Matthew stretched his hands over the sea to part the water. Importantly, we had, like I said, we had familiar stories and we also had unfamiliar stories. An example, oops. Oh, okay. That's easily remedied. So I'm going to have to, I think, go through everything to get there, because I don't know how to get there faster. I know there's a way to do it, but it's probably easier. I'll get there. I know it's faster to do it the other way. Okay, almost there. Sorry, not sure what's going on. I'll try to get there the quick way this time. Oh, yeah, that's good. Okay, start there.
So we'll just do like this, right?
Yeah.
So it'll look like this.
Oh, okay.
Just go down here when you're ready.
Oh, okay, just go like that?
Yeah.
Okay, cool. And then I'll go back to the regular view after this.
Yes, then you just press the, I think it's this one down there.
Oh, great, okay. So this is an example of one of the unfamiliar stories. Has anybody ever heard this story, Elijah and the Flour and Oil? Okay, all right. So in this story, a man named Elijah is hiding from the mean king and needs help, so God tells him to pack up all of his stuff. And so Elijah packs up his stuff and he goes to this woman way out in the middle of the desert somewhere, and he brings this giant sort of group or army of people and says that she needs to feed all of them. And this is a poor woman, and all she has is a tiny bit of flour and oil, so she's really stressed out by this request. But God basically has promised to Elijah that the flour and oil will multiply, and so she feeds them, and sure enough, every day more flour and oil appears, and she's able to feed this big group of people. In the non-religious version, as you can see, Ethan is hiding from the mayor of Morgantown, and the story goes on, and basically his father tells him what to do, and he goes and visits this woman, and the same kind of stuff happens. So let me try this presenter view again. Okay, so this is what we see in the results. Again, on the y-axis is the number of claims that these events actually really happened. And then we see children from the religious condition in black and children from the non-religious condition in white. And what we saw was that with age, children increasingly used these cues of God in these stories to infer that the events really happened. And this effect was significant for the 6-year-olds, but it was increasingly kind of going there in the younger children. And so basically, if God is involved in a story, then the event is real, even if that kind of thing could never happen normally. So children were using their beliefs and beliefs about what was real to reason about what kinds of things could happen in the world. Okay, I have 2 more left, and I think I have time. One of what I think is one of the most impressive demonstrations of children's ability to make this distinction is when children can use their own knowledge about what exists and kind of assess the fit between that knowledge and the novel information, and then kind of use the product of that computation to make a judgment. So Gabe Lopez-Mobilia and I presented children with novel animals again, but we presented them with different types. So we presented them with what we called possible typical entities, possible atypical entities, and impossible entities. So a possible typical entity, we told them about a binbad. And we told them that a binbad is a kind of bird that eats bugs. So here, this is something that was consistent with what they know about the world. For the possible atypical entities, we told them about a binbad that was a kind of bird that had a blue beak. So again, it wasn't inconsistent with what they knew, but it wasn't typical. And then in the impossible condition, a binbad is a kind of bird that can become invisible. So here's something that was totally inconsistent with their knowledge about the world. And so we were interested in seeing whether they would use their knowledge about what exists in the world to reason about the likelihood that these new kinds of things could exist. The way the task worked is that we first gave them children a choice of guessing right away about whether these things were real or not real, or asking for help from an informant. If they wanted to guess, we let them guess. We could say whether they thought it was real or not real. But regardless of whether they guessed or not, all children heard testimony from these informants. Half of the time the informant said that the entity was real, and half of the time the entity said that the informant said that the entity was not real. And then finally we got their final judgment about whether the entities were real or not real. So I'll just briefly state the results of the different questions to begin. We found that children chose to guess most often on the impossible entities, so they didn't want any help, they just knew right away these things were not real. So they chose to guess more often they chose to guess most often on the impossible trials, as I said. What did they guess? They guessed that they were real most often on the possible typical trials, and then next most often on the possible atypical, and least often on the impossible trials. So when they didn't want to guess, they knew it was impossible, that was good. So they were using their knowledge about what exists to make these distinctions. And then they also used testimony to make these distinctions. Again, the same kind of pattern. So what I want to show you in the next graph is how testimony affected children's judgments. And so again, mean real responses on the y-axis, possible typical, possible atypical, and impossible, other kinds of entities. And what you see in the bars are children's final decisions after they heard the testimony. So when the informant said the entity was real, that's in the light gray bars, and when the informant said that the entity was not real, that's the dark gray bars. And what the dashed lines show you is what children's initial guesses were. Okay? So starting with the impossible, there, you can see the little dashed bar. Children were basically guessing, as I said, that these impossible entities were not real, just right off the bat. But if they did hear testimony that asserted that these entities were real, there was kind of a little bit of movement. So some kids kind of changed their answer and said, well, maybe it could be real. If you look at the possible typical, you also see movement there. So pretty much, for the most part, children guessed that these entities were real. But then if they heard somebody say they weren't real, there was a fair amount of movement down toward agreeing that maybe they actually weren't real. But what's interesting to me is that I think the most movement was here in the possible atypical trials. They moved in both directions. So basically they guessed here, but then if they heard that the entities weren't real, they agreed, and if they heard that the entities were real, they agreed with that as well. I mean, not all of them, but for the most part. So I think that testimony turned out to be most valuable when these entities were not contradictory, but just kind of not the usual, not what they're sort of used to hearing about. So kind of inconclusive, but not entirely inconsistent. So this study shows that children can reason about what they know and apply it to novel entities. I've focused most, on group differences now, age differences, and various other factors. And the last thing that I want to mention is I'm really intrigued by individual differences. Why some kids think things are real and other kids think things are not real. And so the last study that I'm going to talk about addresses this. It's a new exploration. And what we're looking at is the relation between children's metacognitive estimates of their own expertise and their judgments about reality status. So in a lot of the studies that we've done in my lab, we found that children are actually pretty skeptical, and you may have picked that up from a lot of the graphs that I showed you today. They very often will claim that entities are not real. Even with no information, they seem very sure about it. What's really interesting is that I know some of you know that kids are obsessed with animals. A lot of them are very fascinated by animals. And they seem to think they've heard of them all by the time they're 4, which I find to be absolutely fascinating. So, what they'll say when we ask them why a particular entity isn't real is they'll say because they've never seen one, or because they've never heard of it. And you just kind of want to go, hey, what? You're 4. What are you talking about? So it occurred to us that maybe children's overestimation of their knowledge about animals was kind of causing them to make premature decisions about the animal's reality status, and hence to sort of stop them from seeking more information that they could actually use to come to a correct decision about these kinds of things. So to investigate this, Kelsey, Kelly, and I presented children with novel animals like a Cernet. We just showed them, the cards like we did before. And we had children sort them into one of three boxes. A real box, marked by a cat, a not real box, marked by a singing fish, and a don't know box, marked with a question mark. We gave them a bunch of practice trials so they could get used to using all of these boxes. And basically, we had children judge these novel animals as to whether they were real or not real. We also had kind of a control, just an additional task. We were kind of curious to see whether this overestimation of their knowledge would affect sort of similar kinds of judgments. So we had kids judge whether a familiar animal had a novel body part, an amygdala. And then we also had kids estimate their knowledge about animals, just with 2 questions. So we asked them, do you know a lot or a little about animals? And we asked them, do you know more than other people, less than other people, or about the same as other people? So that's what we used to assess their metacognitive knowledge. Just briefly, kids were about 50-50 split into kids who said they knew a lot about animals and kids who said they knew a little about animals. On the novel animal task, they were actually saying that they didn't know more often than they said either of the other 2 options. Not real was more common than real. On the novel body part, 4-year-olds were kind of equally distributed. The 6-year-olds said don't know most often, and the 8-year-olds were getting a little skeptical, saying no more often than don't know. But the really interesting finding was, I'm going to go just a minute over, so I'm almost done. The really interesting finding was that kids who thought they were animal experts didn't want to say don't know for the novel animal task. They either said the animal was real or that it was not real. Whereas the kids who said, oh, they just knew a little bit about animals were much more likely to pick the don't know box for the novel animal. And there were no age differences. We just got this pattern in all of the age groups. So just looking, here's just a little graph I'll go over just really quickly. If you just look at the darker bars, that's kids who said a little. The lighter bars are kids who said a lot. Across those first 3 tasks, I haven't talked about that last one. We can talk about that later if we have time in the question period. But basically, if you look across those first 3 groups, you see that for all of those kids who said they knew a little about animals, were much more likely to say don't know than kids who said they knew a lot about animals. So just one last thing. One thing that's really interesting was that these expert kids claimed that the animals were real more than the non-expert kids, but they also claimed that the animals were not real more often than the non-expert kids. So we had kind of both types of error, if you want to call it an error. And it's really kind of interesting to think about, what's going on with these two. I mean, the one group of children seemed to just deny the reality status of the entities just sort of across the board and cite their lack of experience as a reason. I've never heard of it. I've never seen it before. And it does seem to be the case across a number of studies in our lab lately that young kids rely on their personal experience to make these kinds of judgments a lot more than older kids and adults do. If I haven't seen it, it's not real. End of story. But the other group, the kids who are doing the opposite, that's really interesting, right? They're just claiming that all of these entities are real. And we're not really sure what's going on with that, but there's this really interesting finding in the adult literature of something called overclaiming. And basically people who rate themselves as more expert in a particular domain are more likely to say that various made-up things in that domain are real. So people who rate themselves high on biological knowledge will tell you that things like metrotoxins and retroplex are real, even though they're completely made up. So we're hoping to explore, these interesting individual differences and see if maybe those ideas are what's actually going on with these kids. But in general, in many cases when we encounter novel entities or things in the world, we don't have enough information to tell whether they're real or not real. If understanding that we don't know allows us to kind of withhold judgment and then seek further information so that we can eventually come to a correct decision about reality status. And I think this is something that's really important and something that we use across all domains, not just things domain. So just concluding, I've argued that children use cues and use their beliefs to make these decisions. They use physical evidence, cues in the language, contextual cues. They reason about what they already know and already exists, and they also use their own expertise, although this doesn't turn out to always be a good thing. But studying how kids make this distinction between reality and non-reality provides a window, I think, onto their thinking more generally. And it kind of illuminates how, humans think. In the same way that children's imagination is kind of put to work in thinking about Santa Claus and evaluating these novel entities and events, adults' imagination is put to work in, thinking about the future and contemplating new inventions and all of that. So I think all of this couldn't be done without the ability to imagine the impossible, and I think all of these benefit because we have this special ability. And I just want to thank NICHD, the members of my lab who are shown in the picture, doing the hook 'em horns gesture, all the kids in our studies, and Mark for inviting me, and the center, and all of you for listening today. Thank you.